As we begin our study of calculus, one of the things that we will want to do, because we'll find it helpful, is to look at the characteristics of functions. And one of those characteristics of functions is whether a function is even or odd. So at the end of this lesson, you'll be able to determine if a function is even, odd, or neither. So first of all, let's just look at definitions for even and odd functions. The first one, it says the function y equals f of x is even if f of negative x equals f of x. It's symmetric with respect to the y-axis. So I'm just going to show you a couple examples of even functions and see if we can get this to make a little sense. All right, an even function, if it's symmetric with respect to the y-axis is acting like a mirror. So you will notice that that would be an even function. Let me see if I can draw another even function. I know the cosine function is an even function. So this would be like y equals cosine x. This one would be y equals x squared. Notice that this is an even power. That does make an even function, but it doesn't have to have a power on it to be even. And then let's look at the f of negative x is equal to f of x. Basically what that means is, let's say I have this x value over here is 2, 4. Over here, it would be the point negative 2, 4. And what this means is if I had the y value at x is the exact same as the y value at negative x, and that shows in this picture. Same thing here. If I had, where does that hit at? I believe it hits at pi over 2, so that would be at pi over 2, 0. And this would be at negative pi over 2, 0. And if you look at that, whether it's x or negative x, the y value is the same, and that's what makes it, at least algebraically, an even function. Okay, and then if we look at odd functions, it says an odd function is the function y equals f of x is odd if f of negative x is equal to negative f of x. It's symmetric with respect to the origin. And let me just draw a picture and then we can look more in detail about that. So an odd function would look like this. Okay, and this is the graph of y equals x cubed. Notice it is an odd power, and that will be an odd function if that does happen. But the reason that it is odd, if it's symmetric with respect to the origin, that means it has rotation symmetry. So if I were to turn the screen upside down, I would have the exact same picture. So that's what symmetric with respect to the origin means. And if I were to pick a point on here, let's say this point is 2, 8. This point down here is actually going to be negative 2, negative 8. And notice what this is saying is if I take f of negative x, so here's my x is 2 and here is the opposite of x, I'm going to get the opposite answer for my y value. So when I had 2, 8, and then when I took negative 2, I got the opposite of the y value. So that's what that means. Another example of an odd function, we don't always have to have an odd power when we do that, would be the sine function. So if I looked at something that looks like that, this would be pi 0. Well, that's not a really good example, is it? We'll do right here. Let's do, this would be pi over 2, 1, and this is negative pi over 2, negative 1. So notice when the x's are opposites, their y values are opposites, and that's exactly what this is saying. And when it asks you to show whether a function is even or odd, we're actually going to use these two tests right here. We can kind of get an idea of what we think it will be, and then we'll use that to actually verify it. So let's go ahead and do a couple examples. The example says to determine whether the function is even, odd, or neither. Use a graphing utility to verify your results. So if I look at this one, f of x equals the cube root of x. I'm going to guess that it's going to be odd because there is an odd root going on. So I'm going to do my check for odd. And we know the check for odd is f of negative x is equal to negative f of x. And now we're actually just going to do some substitution to figure this out. So it tells us to do f of negative x, which means in this problem, wherever I see an x, I'm going to put a negative x. So I'm going to put a negative inside there. Okay? And then if you recall from this, negative x really just means negative 1x. And then I can actually separate this into the cube root of negative 1 times the cube root of x. And the cube root of negative 1, what times what times what, gives me negative 1. That would be negative 1. And then the cube root of x just stays the cube root of x. So that's the left side. And then this one says, on the right side, to take the opposite of f of x. Well, f of x is the cube root of x, and then taking the opposite would make it negative. So if I just put down here, notice we get the same thing. So that shows that this is an odd function. All right, and when it said to use a graphing utility to verify your result, then we could actually just take our calculator out and graph it, and we should get something that looks like that. So definitely it is an odd function, because if I were to turn my paper upside down, that would look like the same picture as it looks like right now. Okay, if I do another example, determine whether the function is even, odd, or neither again, and then use a graphing utility to verify your result. This says y equals x squared plus 3. I have a strong feeling that this is going to be an even function because of the squared, so that's the test I'm going to do first. If one of my tests failed though, then I should probably try the other one to see. So my even test is f of negative x is equal to f of x. And then again, I'm just going to go ahead and do each side. So the left side means wherever I see an x in this function, that I'm going to replace it with a negative x. So I'm going to put negative x squared plus 3. Please notice that I did put the negative x in parentheses. Now when I take a negative x and square it, negative x times itself will just be x squared plus 3. So that's as far as I can go on the left side. The right side just says to write down f of x. So if I write down f of x, that is x squared plus 3. Notice I get the same thing, so it is an even function. And then verifying it with our graphing calculator, we'd have y equals x squared plus 3. If you were to graph that, we'll end up getting a parabola up at 3. And notice that that is an even function because this graph is symmetric with respect to the x-axis. With the y-axis, excuse me. We will come into some cases where we will get neither. As an example, if you can think of it, if I had something like y equals x squared plus x minus 2, we'll have a function that looks like that. Notice it kind of looks like it's going to be an even function because we have an even power, but when we were to graph that, or we did the test for it, either one, I'm just trying to think of where this is going to touch. I think it's going to touch at -2, and I think it's going to touch at 1. We're going to get something that looks like that. That might look like it's an even function, but it's not, because it does not have symmetry with respect to the y-axis. So that would be a case where that is neither. So hopefully now you are able to determine if a function is even, odd, or neither.